Good morning, children. We are on to the next lecture on P block elements, that is group 13 and 14 elements, class 11. In the previous video, I have discussed the questions up till 20. So from here, I am continuing further. Okay. Now, suppose a question is asked, this is known whereas this is not. Means silicon F6 2- is known, but with chlorine it is not known. We are doing reason questions. Okay, so before you watch this video, please watch the previous video. Right? So this is known, the other one is not known. Why? Now first thing is silicon can have 6 coordination number for sure because silicon has d orbital. Then with fluorine it is capable of making such a compound, with chlorine it is not, because fluorine is small in size. Because it is small in size, small fluorine atoms, 6 of them can surround silicon, whereas chlorine is larger in size. It is having large size, so it is not possible for 6 chlorine atom to surround silicon. So there will be hindrance. There will be steric hindrance. Due to hindrance, the 6 chlorine cannot surround silicon even though there is availability of d orbital. Right? Now, the next question says, diamond is covalent yet it is high melting solid. Now, in this you can talk about hybridization. The carbon atom in diamond is sp3 hybridized. sp3 hybridized means each carbon atom is tetrahedrally surrounded by 4 carbon atoms. Okay, so between carbon there is a sigma bond only present and it forms a network like structure. It forms network like structure. Okay, so because of the formation of the network like structure, it is very rigid. It is very rigid and it has high melting point. It is having high melting point. Okay. Now, with reference to diamond, another question also can be asked, like diamond is transparent. Diamond is transparent. Give reason for that. It is transparent. Now, why it is transparent? What will you write in this? Because diamond has high refractive index. It has high refractive index and the value is 2.5. So diamond can reflect and refract light. Therefore, it is transparent. It can reflect and refract the light. Therefore, it is transparent. So even this can be a reason question asked. Right? Moving on to the next question, which says diamond is a poor conductor of heat and electricity. Now, recently we studied that carbon in diamond is sp3 hybridized. sp3 means it is tetrahedrally surrounded by 4 carbon atoms. Okay, the bond angle will be the same as 109 degree 28 minutes. No electron is free. 4 electrons are there in the valence shell. All 4 electrons are involved in the bond formation. So there is no free electron available in diamond, therefore it is a poor conductor of heat and electricity. Okay, it is not having any free electron, all 4 are involved in the bond formation. Okay, one more thing you can remember here is the carbon-carbon bond length in diamond is 1.54 angstrom unit. Right, this much is the bond length. But anyway, when you are answering for the poor conductor, you will just write down there are no free electrons. It is having sp3 hybridization and all 4 electrons are involved in the bond formation. Okay. Now, the next question says graphite is soft and slippery. For this, you should have little idea about the structure of diamond. Graphite. Structure of graphite. Graphite mein carbon is having sp2 hybridization. sp2 hybridization means it is having trigonal planar structure. So likewise, each carbon atom will be trigonal planar. Okay, each carbon atom will be trigonal planar and it will have number of hexagonal rings like this in each plane. There will be another plane, another layer also like this in which there are hexagonal rings. So in graphite, each carbon atom is sp2 hybridized and it forms a trigonal planar like structure, and when number of carbon atoms are joined together it forms hexagonal rings. There are many such layers in graphite in which each layer is having a hexagonal ring. Right. So this carbon in the ring is surrounded by 3 carbon atoms. So that means it is 120 degree. Right. And if you check, this bond length over here is 1.41 angstrom unit. But if you check this bond between the hexagonal rings of one layer and the another layer, there are weak van der Waals forces of attraction. There are weak van der Waals forces of attraction. So because of the presence of the weak van der Waals forces of attraction, these layers can slip over each other. So what will happen? Graphite, these bonds can break very fast. These bonds can break very fast, and this bond length is more. It's nearly 3.4 angstrom unit. Okay, so when graphite breaks, these layers will slip over each other. When they slip over each other, because these bonds are very weak, they can slip over each other. Due to that, it is soft and slippery. And due to that, we also say graphite always breaks in layers. It breaks in layers because these layers are there. They slip over each other and then they break it. Okay. Now, in the same answer you can give for this one also. Graphite is used as a lubricant. Why it is used as a lubricant? Because the weak forces are there between the hexagonal rings. They can slip over each other. So for this and for this one, you can have nearly similar answer. Okay, these are different types of the questions which can be framed. The next one says graphite is a good conductor of electricity. In this we wrote just now carbon is sp2 hybridized. So structural aspect has to be covered to answer this question. Okay, because sp2 hybridization, each carbon atom has one electron which has not participated in the bond formation, which has not participated in the hybridization. So it is having one free electron. So it is having the electron cloud above the plane, below the plane. Due to the presence of this free electron, it is a good conductor. It is a good conductor of heat and electricity. That is why we say graphite is used as an electrode. In electrochemistry, you will study that. It is used as the electrode because it has a tendency to allow the electric current to pass through it. Okay. The next question says diamond is used as an abrasive. In this you can talk about diamond structure again. You can write down each carbon atom is sp3 hybridized. The tetrahedral arrangement is there. Carbon-carbon bonds are strong. It forms a 3D network like structure, or you can say diamond is a 3D network solid. Okay, due to which it is hardest substance known. It is the hardest substance. Okay, therefore we say it is having high density, it is having high melting point. Because it is hard, it is used as an abrasive. Okay, the next question says lead is unaffected by water. So for this you will write down lead forms a protective oxide layer around it. Which protective oxide layer it is forming? It is forming of lead oxide. So lead oxide is formed around lead, so further reaction will be stopped. So similar property we have studied for beryllium, we have studied for aluminium, and now we are studying for lead. Okay. A similar question can be asked with reference to carbon, silicon, germanium. They do not decompose water at all. Okay, first of all, you should know the property, like carbon is a non-metal, and we know that silicon, germanium, slightly metalloids. They have the property of metal and non-metal both. They are small in size. Due to small size, their reactivity is less, so they do not decompose water. For lead, it was more reactive, but it cannot react to some, it can react only to some extent, form a protective oxide layer. After that it will not react. There is only one element in this 14th group which can react, that is tin. So you can write down tin with water. It decomposes water and it results in the formation of tin oxide plus hydrogen gas is released. Okay, so side by side you have learned the equation also. The next, it says boron cannot exhibit coordination number more than 4. Why? Because you can write down the configuration for boron. It is 2s2 2p1. It is not having d orbital. The absence of d orbital, due to absence of d orbital, boron cannot expand. Boron cannot have more number of the electrons taken from the surrounding. So maximum coordination number which it can have is 4, wherein you have 2s 1 orbital and in 2p you have 3 orbitals, so put together only 4. So it cannot have more than 4, but the other elements in the same group can have up to 6 also, because of availability of the d orbital. First ionization enthalpy of the elements of group 14 follows this order. Why? Now what you observe in the order is carbon, silicon till this tin, ionization enthalpy is decreasing, and then for lead it is more. Now we know lead lies in which group? Lead lies in group, it lies in which period I wanted to say, that is in the 6th period it is lying. Okay, so 6th period, the valence shell configuration is 6s2 6p2, right? So before that there are lanthanides. It is one of the post-lanthanide elements. In all the post-lanthanide elements, we know that the 6s pair, okay, this pair becomes inert. The effect is called as inert pair effect. So due to inert pair effect, which is one of the consequence of lanthanide contraction, this 6s2 does not participate in the bond formation. And moreover, due to lanthanide contraction, what happens is the size of lead is less. So when size is less, because the nuclear charge is more, in case of lead, the nuclear charge is more. Why it is more? Because in all the post-lanthanide elements, the size is comparatively lesser than expected because of the poor shielding of the f orbital. Okay, so because of the poor shielding of the f orbital, the nuclear charge is comparatively more in lead. That is why it is having more, ionization enthalpy than the lead, than the tin, the previous element. Okay, I hope this part is clear. So you will write down why is lead having comparatively more ionization enthalpy. That's because of the nuclear charge. Actually, that inert pair effect you needn't specify here. You can just specify because of lanthanide contraction, the size is comparatively less. Okay, so when we are talking about the inert pair effect, means we should be relating to oxidation state. Okay, that question will come later. So there we will talk about it. Right. So carbon exhibits all oxidation states from -4 to +4. First of all, 14th group elements, the configuration is NS2, NP2. Right. So it is having 4 electrons in the valence shell. So it's on the borderline. It can take 4 to acquire octet. It can allow these 4 to participate to have +4 oxidation state. So carbon, being the smallest element of group 14, it is the smallest element of group 14, due to which what will happen? Due to which it can take the electrons and it can allow all 4 also to participate, so it can have a complete range of the oxidation states. Right, but when you compare, the next question is in continuation, the stability of the negative oxidation states decreases down the group. Because if you consider the elements carbon, silicon, germanium, tin and lead, okay, down the group the size is increasing. When size increases, the stability of the negative oxidation state will decrease. The first element can have all oxidation states -4 से +4, whereas the other elements can have maximum up till +4, but -4 will not be shown by them. And the last element, that is this, will not be able to show 4 also. It will be showing only +2 oxidation state because of inert pair effect. That is one of the consequences of lanthanide contraction. The pair of the s electron gets inert. Okay, so all these questions are related. You can be asked in any form. You can see this one. The stability of +4 oxidation state decreases down the group. That is because of inert pair effect, due to which the last element, that is lead, is not able to show 4. Lead can show only +2 oxidation state, not 4, because of inert pair effect. Clear? Now, similar to that oxidation state only, this question, lead can exhibit +2, not +4. You can write because of inert pair effect. The pair of the s electron doesn't get unpaired. It doesn't participate in the bond formation. It's one of the consequences of lanthanide contraction. Right. The next question says the carbon tetrachloride cannot be hydrolyzed, whereas silicon tetrachloride can be. You will write down carbon tetrachloride में carbon does not have d orbital. Absence of d orbital, due to which it cannot take in electron pairs of water molecule. It cannot take in electrons from the water molecule. That is why it cannot undergo hydrolyze. Whereas if you write down for silicon tetrachloride, this can undergo hydrolysis. Okay. You can further write down the equation also with respect to this one. Silicon tetrachloride, SiCl4, it can combine with 4 water molecules and it forms SiOH taken 4 times plus 4 HCl. What is this product called? It is silicic acid. Silicic acid. So how do you remember this? Actually, it's like this. Silicon tetrachloride. So you will write down this 4 chlorines around silicon, and each of them is now reacting with water molecules. So 4 water molecules you can write down around silicon tetrachloride. So these 4 water I have written. So each of this will form HCl. So this will come out as HCl over here. So what are you left with? Silicon with 4 OH. So silicon with 4 OH and 4 HCls are formed. This is the product. Right? Carbon can form multiple bonds with oxygen, carbon and nitrogen, whereas other elements cannot. Like you can see carbon, oxygen, there is a double bond possible. There is a carbon-carbon double bond possible, or you can say carbon-carbon triple bond is also possible. There is carbon triple bond N also possible, whereas the similar compounds with silicon, germanium, tin and lead are not possible. The answer to that is carbon has small size. Because it has small size, there is lateral overlapping of the p orbital is possible in it. Lateral overlapping of the p orbital is possible in carbon, whereas when the size of the atom increases, like in silicon, germanium and all that, so when the size of the atom increases, the lateral overlapping is not possible, because when the size is big, the p orbitals will be far away. So even if they bend by the lateral overlapping, even by bending, the overlapping will not be effective. Yes. Carbon exhibits abnormal behavior in group 14. Why? So what you'll write in this is small size of carbon. You can write down high ionization enthalpy. Then you can also write down absence of d orbital. Okay, so due to which carbon is abnormal. Right? Carbon can have maximum coordination number of 4, whereas other elements can have 6. So answer lies here. Carbon can have 4 only because of absence of d orbital. It can have only 2s, 1 orbital, 2p, 3 orbitals, put together only 4. That was the reason we also said that carbon tetrachloride does not undergo hydrolysis, whereas the other elements can. I mean, silicon could, right? So you will write down the other elements can have 6 because they have d orbital. In them there is d orbital available. Carbon mate is not available, right? Mention 4 properties in which carbon exhibits abnormal behavior. So what all properties you have listed you can mention. 1, you can talk about coordination number. Coordination number 4, that is the maximum one carbon can show. That is one of the abnormal property. You can also write about carbon can form multiple bonds. It can form multiple bonds with the small elements like carbon, oxygen, nitrogen. Then you can write down carbon has the maximum catenation property. The maximum catenation property of carbon is also due to the small size. You can also mention about the oxidation states. Carbon can have all possible oxidation states from -4 to +4 including 0 in different compounds. What happens when tin reacts with water? Okay, this equation we have already written. Tin plus water. What will it form? It will form tin oxide plus this will be formed. You can balance it also. 2 here and 2 here will be there. Right? Then, explain structure of fullerenes. Now, in this you can talk about the hybridization. Hybridization is sp2. There are 6 membered rings and 5 membered rings. There are 6 and 5 membered rings in it. Okay. And in fact, you can also mention that there are, you can write down that there are 12 5-membered rings. 12 5-membered rings. And there are 20 6-membered rings. There are 60 vertices. Okay, there are 60 vertices. It's like football like structure. Okay. Another point you can write is that the 5-membered rings are surrounded only by 6-membered rings, and 6-membered rings are surrounded by 5 as well as the 6-membered rings. 5-membered are only surrounded by 6 and 6 are surrounded by 5 and 6-membered rings. Okay, that's it. You cannot draw the structure otherwise because it's a 3D structure. So that's it. I think we have tried to cover most of the questions which can be asked from group 13 and 14. So now you can learn them, and please make notes so that all the questions are together with you. Thank you.